Well, welcome to the third and final video for Chapter 2, Section 4. So far, we spent a video talking about long division, which seems like a very lengthy process. Our second video, we talked a little bit about why this whole division thing might be somewhat important. And in this video, we're going to talk about synthetic division, which is a much easier form of division. It's going to make life a lot easier, make the whole process a lot faster. And I think from that, that's probably what we're going to focus on for most of this section. So with synthetic division, you can only use this if you're dividing by a linear idea. So dividing by x plus a number or x minus a number. If you were to maybe get a linear idea of 2x plus 5 and they said divide by that, you would have to adjust that a little bit to actually use synthetic division. So all of our examples in our notes will be in the form of x plus or minus a number. But some in our book might get a little bit more complicated, and we will go through one of those together at some point. The format for synthetic division is going to look a little different from long division. Similar, but different. And instead of looking at all of the, writing every single thing down, we're just going to take the coefficients. So we're going to look at a 2, a -1, and a 12. But just like the first example in our long division notes, if there are any degrees that are missing here, you need to represent them with a 0. So just be careful with that. So I'm going to list out 2, -1, and 12. And then I'm going to take the number that's in the divisor. So in this case a 3. I need to take the opposite of that number. So a -3. Now the way I choose to do this, and the way our textbook I think shows this, I split them like this. And you might have done that differently in previous classes if you've covered this topic. That's just how I choose to do it. You may use old notation if you'd rather. That's just what I do. Okay, and then basically all we're going to do is we're going to drop the first coefficient. So I'm going to drop, let me get a little arrow here. We're going to drop the 2. Whoops, that didn't work. Okay, drop the 2. Then we multiply, so we multiply this number times what we just dropped, so -3 times 2 is -6. We're going to write it right below the next number in the line, and then we add them. So -1 plus a -6 is -7. And we just keep repeating that until we get to the end of our numbers. So -3 times a -7 now is positive 21. We add those together, we get 33. And right now it just kind of looks like, just a bunch of numbers, no meaning to it. But here's where it kind of comes into play. Okay, just like we did with long division, I can take this and write out an answer now. I can say that I took 2x squared minus x plus 12, I divided by x plus 3, and I actually have an answer. So I think the first thing I'm going to do is show you what this would look like in our factored form. So I'm just going to kind of split this up here a little bit. That was our work. Factored form, fraction form I should say, fraction form, okay, is going to look like this. We just took 2x squared minus x plus 12. We're going to divide it by x plus 3. And when I did that, this is what my answer is. This is what this bottom row here tells me. Okay, remember that my overall degree for this was x squared. I drop a degree in my answer. So this is now going to represent 2x. I started with x squared. This is now the coefficient for 1 degree less. So I have 2x minus 7. Okay. And then the last number, the 33, that is my remainder. So I have a remainder of 33 that still needs to be divided by the x plus 3. Okay, so again, how do I come up with the answer from this? Okay, we got the original fraction by saying take this divided by x plus 3. But then the 2x minus 7, that comes from this. The first degree that I put down is going to be 1 degree less than the starting original degree, and then my final number is my remainder. Now, if you look really carefully at this, this is the exact same question we had in part C of our notes, where they just said find the remainder. So this is also a verification of the remainder theorem. We do get 33 as our remainder when we go through and do our division. So just a little side note there. So again, this was fraction form. We also have polynomial form, and for that we would say that 2x squared minus x plus 12 is going to equal our divisor, which was x plus 3, times the quotient, which was 2x minus 7, plus the remainder of 33. So we can still put them together the same way we did with long division, but obviously this just goes a lot faster, especially once you get really good at it. And our last example here, this is the same thing as, I believe, part D in our notes, where we're proving the remainder theorem. I'm sorry, the factor theorem, is it called? Yep, factor theorem. I should probably know this. I'm teaching the course. But we're going to set up the same way, just another little verification that we know how to do synthetic division. So we take the coefficients from the original, so 2, a negative 3, a negative 5, a negative 12. Okay, you take the opposite of the number that's in the divisor, so I see a minus 3 there. I'm going to take a positive 3 and put it in this little box. You may do that differently if you want. And then I would just challenge you right now, pause the video, try to do this on your own and see if you come up with the right answer. And hopefully you did that. I'm just going to quick walk you through what would happen here. We said drop the first number, so drop the 2, multiply it by that number in the box, so 2 times 3 is 6. Come on. Let's see if I can quickly erase that. There we go. Okay, we get a 6. Add those together, so we get a 3. Multiply by the number that is in the box there, so 3 times 3 is 9. If we add those together, negative 5 and 9, we get 4. 3 times 4 is 12. Add that to the negative 12, we get 0. Okay, so what does this all mean if I put it into fraction form? I just took 2x cubed minus 3x squared minus 5x minus 12. I divided it by x minus 3. My answer for that was 2x. Now, what's the power now? Well, the original power was a 3, so this one has to be a 1 less, so it'll be 2x squared. Then we have a 3, so plus 3x, and then a 4, so plus 4. My remainder is 0, so I have nothing left over. That's a good thing, generally speaking, so I can just stop right there for the fraction form. And then polynomial form would be take the original, so 2x cubed minus 3x squared minus 5x minus 12. It's going to equal the divisor, which was x minus 3, times the quotient, which was 2x squared plus 3x plus 4. Okay, so again, this was the fraction form. This was the polynomial form. Okay, a couple quick examples there. Again, we verified the factor theorem here. We did get a remainder of 0, so that's a good thing. We can say x minus 3 is a factor of that function, but we also just verified synthetic division a little bit too. So, again, as always, jot down any questions. We'll see you in class.